Checking a solution. A solution is made up of two equal expressions. And a solution is the value of the variable that makes the equation true. So let's go ahead and look at example 1. Does E equal 1.60 volts if there are two 12 AWG conductors with a resistance of 0.2 ohms supplying a 16 amp load that is 50 feet from the power supply? So we need to confirm that the calculation done is correct. So we have E, which is equal to 1.6 volts. We have a resistance of R equals 0.2. And then we have an I of 16. So let's go ahead and plug in these numbers. But we're first going to make sure that 1.6 is equal to, then when we do this, 0.2 times 16. So how we would do this, we would just need to multiply the right-hand side in order to confirm that we get 1.6. So we have 16 times 0.2. 6 times 2 is 12, carry the 1. 2 times 1 is 2, plus 1 is 3. Then we need to deal with 1 decimal, so we bring it over to 1, and we get 3.2. So if we get 3.2 volts on the right-hand side and we get 1.6 volts on the left-hand side, this in fact does not mean that they are equal, and so therefore E does not equal 1.6. So that is how we can check a solution. So let's look at example 2. Example 2, is x equal to 4 the solution to negative 3x plus 6 equal to 1? So with x equals 4, we're going to plug in that number 4 into x anytime we see it. So we have negative 3 times 4 plus 6 equals to 1. So here we have negative 3 times 4. That's negative 12 plus 6 equals 1. So negative 12 plus 6. We can look at this as 12 minus 6 and keep the sign of the negative, which is just equal to negative 6 is equal to 1. And we would say these are not two equal expressions because negative 6 is not equal to 1. So this is not a solution.